Okay, this is the lesson for the afternoon of Monday. I believe it's April 5th, so it's our second to last day in class, and this is combined gas laws. So basically what you're doing is you're taking what you did in the morning and you're putting everything together in one formula. So in the morning we had P1 times V1, we have P1 over T1, and V1 over T1. So we're just combining everything in one law. Important reminders, make sure the temperature is in Kelvin. So let's say it's 20 degrees, you have to add 273. So always add 273 to the Celsius to get it into Kelvins. Pressures must be in the same units. It doesn't matter which units you use for pressure, but you've got to use the same one. So if it's ATMs on the left side of the equation, it's ATMs on the right. Volumes must be in the same units. So if you got liters on the left, it must be liters on the right. So don't mix units when you're doing the problems, although the equation is very forgiving. Let's try two problems. 2 liters of a gas at 2 ATM and 300 K. So that's what you're starting with. You're starting with 2 ATMs of gas. You're starting with 2 liters at 300 K. And now there's a change. Are placed under 4 ATM of pressure at 400 K. What is the new volume of the gas? So the old is the P1 V1 T1. The new is the P2 V2 T2. So now you have to know how to rearrange a formula. If you want to isolate this V, you've got to get rid of the 4. If it's on the top of this side of the equation, if you move it down here, it goes to the bottom. So, now the question is, we've got 400 K here, how do we get rid of it? If it's on the bottom of this side, we move it over, we move it up, and we multiply. So we would have 400 times 2 is 800 times 2 is 1600 divided by 300 times 4, which is 1200. So 1600 divided by 1200 is 1.33. So our V2 is 1.33 liters. So as you can see, the volume went from 2 liters and it went down to 1.33 liters. Let's try one more problem, and you guys will have 5 of these to work on today. So remember what I said, the sheets that you printed off this morning are all the sheets you need for this mini unit, which is only a day and a half long, and you're going to do the 5 combined gas law problems. I believe it's either 4 or 5 that you have to do this afternoon. So if it's a combined gas law, meaning if it has volume, pressure, and temperature in the question, automatically write this down. Sometimes we get stuck just looking at a problem instead of starting to write things down. So 2 liters of a gas at 2 ATM and 300 K. So we got 2 liters, we've got 2 ATM, and we've got 300 K. Is placed under 4 ATM of pressure. So we've got a new pressure in a 1 liter container. So we've got a new size of container. What is the new temperature of this system? Folks, the reason I wanted to ask this question is to show you when a variable's on the bottom, flip both sides of the equation. It's much easier to work with a variable when it's on top. Remember, we want to isolate the T2, so we have to get rid of this. If it's on the bottom on this side, we multiply it by this. 4 times 1 times 300 is 1200 over 2 times 2 is 4. So our new temperature is going to be 300 Kelvin. So our temperature did not change at all, because the changes that we made canceled each other out. So the changes we made to pressure and volume canceled each other out. So the temperature remained constant from the beginning to the end.